Welcome to the Math Olympiad. Let's learn the progression problems more now, which are either from Mathematics Olympiad or from JEE and BITSAT and other entrance exams, which can be solved by 10th class students mainly. Okay, I am targeting these problems mainly from Olympiad, class 8th to class 12th. But I have taken problems from various exams which are for meant for the Olympiad, who can 10th class students can actually excel in that. Okay, let's get into the progressions. So before going into the progressions, I have made actually 10th class lesson for progressions actually. You can see my videos in the 10th class Telangana 10th class maths book lessons. Okay, arithmetic progressions and geometric progressions, I made a very detailed lesson there. That will be very helpful for you if you. It is good if you first solve that and then come to these videos actually. The summary is mentioned here. Okay, in arithmetic progression, okay, which we represent by AP, the terms of AP are A plus D, A plus 2D, A plus 3D, and so on. Okay, the given list of numbers A1, A2, A3 is an AP if the differences of consecutive terms, okay, is constant. Okay, that is A2 minus A1, A3 minus A2, A4 minus A3. Okay, this will give the same value, that is common difference. Okay, so if I represent it, AK plus 1 minus AK is same for different values of K. Okay, this is called common difference. We represent normally with D. Okay, in an AP, the nth term is generally given by an equal to a plus n minus 1 into D. Okay, the sum of first n terms of the AP is s equal to n by 2 into 2a plus n minus 1 into D. Okay, if the last term of the infinite AP, if a finite AP is given, then nth term is equal to s equal to n by 2 into a plus L. Okay, if you see it clearly, you can, I am splitting this 2a into a plus a. So a plus n minus 1d is nth term, basically an, right, which is last term. So s equal to n by 2 into a plus L. Okay, this is the equations for arithmetic progression, which are very simple, but you will find many different types of problems. Okay, now about geometric progression, the summary is general form of geometric progression is AR square, AR cube, and dash dash dash. Okay, the first term is and common ratio of GP are A and R respectively. Okay, A is the first term, R is the common ratio. Then nth term is AN equal to AR to the power of n minus 1. Okay, AR to the power of n minus 1. Here A is not equal to 0, R is not equal to 0, and also R is not equal to 1. Okay, if R is 1, what happens is the progression always have same term, basically a comma a comma a comma a, which you can tell it is a arithmetic progression also. Okay, now in geometric progression, for sum of n terms, you have two equations depending on r value is greater than 1 or r value is less than 1. Okay, so Sn equal to sum of n terms equal to a into r to the power of n minus 1 divided by r minus 1 if r is greater than 1. If r is less than 1, then you have Sn equal to a into 1 minus r power n divided by 1 minus r. Okay, then these are the two terms, arithmetic mean and geometric mean, which normally in most of the exams they will tell to confuse you and take you away from basically take you to AP and GP. Okay, so just note down very carefully, this is AM, arithmetic mean is AM. Okay, arithmetic mean is of mean of any series of numbers. Okay, it can be anything, they need not be in a progression, is sum of all the numbers divided by n. Okay, this is what we call average, right, normally. Yes, and the geometric mean of any series of numbers a1 to an is nth root of sorry, this is not plus, this is product, nth root of a1 into a2 into a3 into, okay, this is product, A1 into A2 into A3 into up to AN. Okay. Now AM is greater than GM always. If you want, you can prove that. Okay. AM is always greater than or equal to GM. Arithmetic mean is always greater than or equal to geometric mean. Okay. Now in geometric progression, you have one more equation. Okay. S infinity, sum of infinite terms if R is less than 1. Okay. If normally we learnt if R is less than 1, this is the equation. Okay. But what happens is 1 minus R power n becomes almost equal to 1. R power n will become infinity, right? When n is infinity, R is less than 1, it will become almost 0. So in such cases, S infinity is equal to A by 1 minus R. Okay, this is another equation. So these are all the equations which are from geometric progression and arithmetic progression. Looks very simple, but look at the problems and variety of problems which we can come across in these two topics. Okay. Yeah, that's it. A number 32 is divided into 4 parts that are in AP. Okay. The ratio of first and fourth to that of second and third is 7 is product of, basically the ratio of product of first and fourth terms to that of second and third terms is 7 is to 15. Lowest part is what? Okay. Lowest part, which is the lowest part. Okay. Let's see. So it is given 32 is divided into 4 parts, right? So which means which are in AP. So I will call them A plus D, A plus 2D, A plus 3D. Okay. Right. Sum of these 4 numbers is equal to 32. So that means 4A plus 6D is 32. Right. Then he has given the product of first and fourth. First term is A, fourth term is A plus 3D, and the ratio basically. Okay. Ratio to second and third. Okay, that is A plus D into A plus 2D. Okay, the ratio of this is 7 is to 15. Okay, now if you simplify and take the variables to both sides, this is what you will get. Simplify it further, what you will get is 8A square plus 24AD minus 14D square equal to 0. Okay, this is your E1. Okay, now 4A plus 6D is equal to 32, which means 2A plus 3D is 16, or 2A plus 3D whole square is 256. Correct? So that is nothing but 4A square plus 12AD plus 9D equal to 256. Either you can, other way of solving is replace A value in terms of D in this and rewrite the equation and solve it. That's also one way. But since these terms are matching very close, I thought of doing this way. Okay. So 2E1, 2E2 minus E1 will give us 32D square. If you see, the first two terms will get cancelled. 2E1 if 2E2 if I do, the first two terms of E1 gets cancelled. That's why I just did this square. Okay. 32D square equal to 512 or D equal to plus or minus 4. Okay. Now once you have this one, it's very easy. With D equal to 4, A is 2. With D equal to minus 4, A is 14. Okay, so the series is something like this: 2, 6, 10, 14, or 14, 10, 6, 2. Okay, the lowest part is, which one is the lowest part? 2. That's the answer. Okay, yeah, next. Let A1, A2, A3 up to A49 be in AP such that sigma of k equal to 1 to 12, A 4k plus 1 equal to 416. Okay, so you can see the question there. What is asking is A1 square plus A2 square up to A17 square equal to 140 m. Then what is the value of m? Okay, this came in JEE. Okay, so an equal to a plus n minus 1d, we know it. So a9 plus a43. Why I am doing this a9 plus a43? Okay, just see this. Okay, a9 plus a43 equal to 66, which is given, right? Therefore a plus 8d plus a plus 42d equal to 66. That is 2a plus 50d or sorry, a plus 25d equal to 33. Okay, if you simplify this. Now it is given that sigma k equal to 0 to 12, a 4k plus 1 equal to 416. There are, how many terms are there? Total 13 terms. 0 to 12 is 13 terms, right? Each one has a1 and 4kd, right? So the terms I can write it as a1 plus 4d plus a1 plus 8d dash 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 13 terms basically. That will be equal to 13 a1, sorry, this is a1, 13a1 plus 312d. 13a1 plus 312d, okay, 13a1 plus 312d equal to 416. Okay, now we have another equation, right? With this, a9 plus 24d equal to 32. Okay, so now you solve 1 and 2, what you will get is a equal to 8 and d equal to 1. Okay, this is the values you will get. Now simple. Sigma k equal to 1 to 17, ak square equal to 8 square plus 9 square plus 20 up to 24 whole square, which is equal to, okay, I am writing like this, 1 square to 24 square minus sum of 1 square to 7 square, right? This way I will get this value. Why I am doing this? We know the sum of squares of n integers equation, so we can substitute that. Okay, sum of squares of n integers equal to n into n plus 1 into 2n plus 1 by 6. If you substitute this equation, you get s24 minus s square, that sum of squares of 24 minus sum of squares of up to 7 integers, right? So that is 24 into 25 into 49 by 6 minus 7 into 8 into 15 by 6. So if you simplify, what you will get is 4760, which you can write it as 140 into 34, so which is equal to 140 m, right? So m is 34. That's the answer. Okay, so this is another kind of problem which you can get in progressions. Next. Okay, yeah, a series of 384 consecutive odd integers, okay, consecutive odd integers has a sum that is a perfect fourth power of a positive integer. Okay, it's a sum. If you call it k, then k power 4 it is basically, right? Fourth power of a positive integer. Find the smallest possible sum of this series. Okay, so first thing is, we know that sum of n odd integers is sigma 2n minus 1 equal to n square. Okay, so let there be 284 consecutive odd numbers starts from k plus 1 whose sum is perfect fourth power. Okay, so which means n square minus k square equal to d power 4. Okay, and n minus k equal to 384. Means I have taken 384 consecutive numbers starting from k plus 1. Okay, that means 1 to k also I am adding numbers. So n square is basically 1 to 384, 1 to up to complete set of numbers is n square minus k square. Okay, if I substitute, then k plus 1 to n I will get, correct? So n minus k is 384 and n square minus k square equal to d to the power of 4. This is the main equations which I will derive. Okay, so n plus 4 into 384 equal to d to the power of 4. Okay, or 384 I will write it as 3 into 2 to the power of 7 into n plus 4 equal to d to the power of 4. Now, which means if you observe carefully the above equation, n plus k should have at least 3 to the power of 3 and into 2 to make it a perfect square, correct? Unless you make it 3 to the power of 4, you don't get a perfect square here. So you require n plus k should be 3 to the power of 3 and 2 to the power of 7 should become 2 to the power of 8 to make a perfect square. So 2. So 3 to the power of 3 into 2. This is what is the minimum value of n plus k. Okay, if you see that way, n plus k equal to 54 and n minus k is 384, which we know here, right? So if you solve these two, what we will get is n equal to 219 and k equal to minus 165. Okay, the AP starts from 2 into minus 165 plus 1 minus 1, that is equal to minus 329. Okay, I am replacing this equation 2n minus 1 basically. Okay, n is 160 minus 165 plus 1, k plus 1 it starts, right? So minus 165 plus 1 minus 1, okay, which is minus 329. So the equation looks something like this: minus 329 minus 327 dash 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 up to 437. Okay, so sum of these is basically, if a equal to minus 329, L is 437 and n is equal to 384. Okay, with that, if I find the sum, it is 384 by 2 into first term plus last term, right? I'll get the value as 20,736. This is the smallest possible sum of these 384 numbers. Okay, this is another kind of problem. You will get such kind of problems. Next, an increasing GP, geometric progression, is formed by three positive numbers. Okay, the new numbers form an AP if the middle term of the geometric progression is doubled. Okay, find the common ratio of the GP. Okay, so first is given is GP. So let's take GP, A, AR and AR square. These are the three numbers which are in GP. Okay, double of middle term is 2 times AR. Okay, now 2AR, AR square are in AP. Correct? So 2AR equal to average of neighboring terms, that is A plus AR square by 2, or if I simplify it further, R square minus 4R plus 1 equal to 0. Okay, if I solve this quadratic equation, R is equal to 2 plus or minus square root of 3. Okay, now this is the common ratio, right? This is given that GP is in increasing GP. It is given as increasing GP, right? The question is increasing GP. So 2 minus square root of 3, it is a negative number, right? It cannot be increasing then. So only possible value is R equal to 2 plus square root of 3. This is the possible value. Next. Okay, this is a PRMO question. It came in 2017. Okay, let UVW be real numbers in geometric progression such that U is greater than V is greater than W in the order. Suppose U to the power of 40 equal to V to the power of n equal to W to the power of 60, then what is the value of n? Okay, so this is interesting. They are in UVW are in GP, which means U equal to A, V equal to AR and W equal to AR square. Okay, and it is also given U is greater than V is greater than W, that means R is positive and more than 1. Okay, so A to the power of 40 equal to U to the power of 40 is A to the power of 40, right? A to the power of 40 equal to AR square to the power of 60. Okay, from this I can derive and of course A to the power of 40 equal to AR to the power of n. This is another equation. Okay, so A to the power of 40 equal to AR square whole to the power of 60. I can derive A to the power of 20 into R to the power of 120 equal to 1. Okay, you apply 20th square root on both sides. What you will get is A R power 6 equal to 1 or A equal to R to the power of minus 6. Okay, this is one equation. Now you substitute this in the second equation, which is A to the power of 40 equal to AR to the power of n. Correct? So if I substitute this A equal to R to the power of minus 6, then it will become R to the power of minus 240 equal to R to the power of minus 5n, which means 5n is equal to 240 or n equal to 48. Okay, so you can see how what kind of problems you can form using these progressions. Okay, they are all easy. You just need to know very few equations, right? Very few formulae you need to know. Only thing is you apply things correctly. Okay, you apply all the tricks of maths properly. Next, let function is defined as real to real such that for all x belongs to R, 2 to the power of 1 plus x plus 2 to the power of 1 minus x, okay, comma, f of x and 3 to the power of x plus 3 to the power of minus x are in AP. Then what is the minimum value of the function x? Okay, f of x. If you see here, this is very weird. It looks the problem looks very complicated from top, but it's very easy once you see the solution. Okay, see what kind of terms are in AP. Okay, and once you know that three terms are in AP, only thing we know is f of x equal to average of both the terms, neighboring terms, right? So that is 2 to the power of 1 plus x plus 2 to the power of 1 minus x plus 3 to the power of x plus 3 to the power of minus x divided by 2. I'm just writing them two separate sums. Okay, like this. Why I am writing? I'll just get to that. Okay. We know that arithmetic mean is always greater than geometric mean. Okay, we learned this in the summary also. Correct? So, if arithmetic mean is greater than geometric mean, what is the meaning of that? If you see here, this first term is the arithmetic mean, correct, of some two numbers. They can be any numbers. These are the two numbers. This is the arithmetic mean. This is another two numbers. This is the arithmetic mean. Correct? So you apply them individually. This AM is greater than or equal to GM rule. Okay. So we take the second one first. This 3 to the power of x plus 3 to the power of minus x divided by 2 greater than or equal to square root of 3 to the power of x into 3 to the power of minus x. Sum of and product of this, right? GM square root of product. Okay. And this is what is, this gets cancelled each other, right? 1 by 3 to the power of x into 3 to the power of x. That is 1. So greater than or equal to 1. So 3 to the power of x plus 3 to the power of minus x divided by 2 is greater than or equal to 1. This is one equation for us. Second equation also, if you apply same rule, what you will get is 2 to the power of 1 plus x plus 2 to the power of 1 minus x divided by 2 is greater than or equal to 2. Okay, this is your second equation. You substitute these two values in these two equations, you get f of x is greater than or equal to 3. So what is the minimum value of f of x? It's 3. Okay. So these are the interesting problems in progression. Yeah, next. Okay. Let 1 by 16 A and B be in GP, geometric progression, and 1 by A, 1 by B and 6 are in AP, where A comma B is greater than 0. Then 72 into A plus B is equal to what? Okay, this is the question. So we know GP, 3 numbers are in GP, 3 numbers are in AP. Okay, these are in GP, that means middle term square is equal to product of neighboring terms. So A square equal to B by 16, this is for first equation. These three are in AP, 1 by A, 1 by B and 6 are in AP. So we know that 2 by B equal to 6 plus 1 by A. Correct? 2b equal to A plus C, right? That's what we say. So 2 by B equal to 6 plus 1A. This is my second equation. Now just to substitute or eliminate A from these two equations basically. How I have done is E1 into E2. Okay, that is A square into 6 plus 1A. Okay, I am taking A square into 6 plus 1A equal to 2 by B into B by 16, that is 2 by 16, right? B gets cancelled, 2 by 16, that is 1 by 8. So this gives us a quadratic equation 48A square plus 8A minus 1 equal to 0. Okay. Once I solve this quadratic equation, I'm doing factorization method basically. I get two values, A equal to 1 by 12 and minus 1 by 4. It is given that A is greater than 0. So minus 1 by 4 is ruled out, right? So A is equal to 1 by 12. For a equal to 1 by 12, b is 1 by 9, and 72 times a plus b is 14. Okay, this is a bit set question. Okay, next. Five numbers are in AP whose sum is 25. Okay, and the product is 2520. If one of these five numbers is minus of, then the greatest number among these. Okay, what is the greatest number among them? Okay, let's see. Five numbers are in AP, so you take this way. Sorry, I missed one term. You should have one a minus 2d, a minus d, a plus d. Okay, you should have one term here, a plus t. Okay, so these are the five terms which are in AP. Then sum of them is, if I add all of them, basically sorry, this is 5a. I don't know, somehow I did lot of mistakes in this. Okay, 5a equal to 25, all d's gets cancelled, right? Or a equal to 5. Okay, so the product of this one is 2520, which is given. So a minus 2d into a minus d, a into a plus 2d into a plus d into a plus 2d, which is nothing but 25 minus 4d square into 25 minus d square, okay, into 5. A is 5, okay, which is equal to 2520. Okay, so if I simplify, I get a equation in d to the power of 4. Okay, but if you carefully look at, this is a quadratic equation. If you call d square as k, then this is 4k square minus 125k plus 121 equal to 0, right? It's a quadratic equation. Only thing is, roots you will get is d square. Okay, solving this you will get d square, and thus you can derive d from that. D is equal to plus or minus 1 and plus or minus 11 by 2. Okay. If you take d equal to plus or minus 1, the progression is either 3, 4, 5, 6, 7 or 7, 6, 5, 4, 3. Okay, there is no minus of in this, so this is ruled out because it is given that one of the term is minus of. Okay, so for 11 by 2 plus or minus 11 by 2, the series looks like minus 6, minus of 5, 10 and half and 16, or reverse 16, 10 and half, 5, minus of and minus 6. The question asked is, what is the greatest number? Greatest number in this is 16. Okay, please carefully do this problem. I made some mistakes. One term is missing here. This is 5a, and same, the whatever missing term is missed here also. I think copy paste problem. Okay, but rest all the calculation, everything is correct. Yeah, next. Let a1 to a11 be real numbers satisfying a1 equal to 15, 27 minus 2a2 is greater than 0, and ak equal to 2ak minus 1 minus ak minus 2. Okay, 2 ak equal to 2ak minus 1 minus ak minus 2. 2 is here actually, 20. For k equal to 3 to 11. Okay. And another thing is given is, if a1 square plus a2 square up to a11 square is divided by 11 equal to 90, then find the value of this one. Okay. So yeah, this is also ak is given as 2ak minus 1, okay, minus ak minus 2, okay, which is equal to, which means ak minus 1 equal to ak minus 2 plus ak by 2. Okay, this is for all k equal to 3 to 11 terms, correct? So from this we can see that they are in AP, right? The middle term, okay, ak minus 1, ak minus 2 will be ak minus 2, ak minus 1, ak will be in arithmetic progression, only then the middle term is equal to average of neighboring terms. For all terms basically, this is all k equal to 3 to 11. That means if I substitute 3, what I will get is a1, a2, a3, correct? So this is for all the terms basically. So that means this is in arithmetic progression. See, without telling a series is in arithmetic progression, they have given an expression. Okay, so we have to first check this one carefully, then it is very easy to solve the problem. Okay, so once we know that this is an arithmetic progression, I will write things like this. I want to put the middle term as a, and then a minus 5d to a plus 5d. These are the other terms, right? So a minus 5d, a minus 4d, a minus 3d up to a plus 5d. These are my 11 terms. Because they are symmetric, if I sum of them, basically if I sum them up, what I will get is 11a, correct? That's easy. So now it is given that a1 square plus a2 square up to a11 square is divided by 11 is 90. So if I substitute that, then what I will get is, okay, a1 square, a2 square, okay, each one is basically squared. What I will get? There will be 11 a square terms, correct? And how many d square terms will be there? 25, 25, 50, 16 plus 16, okay, 32, 25 plus 32 plus 9 plus 4 plus 1, okay. If I sum up all of them, I will get 110 d squares, okay, and then equal to, correct, each one is a square, right? So all these 2ab terms, that is minus 10ad is cancelled by plus 10ad here, okay, minus 8ad is cancelled by plus ad here, minus 6ad is cancelled by plus 6ad. So all ad terms gets cancelled. Only thing left are 11a square plus 110d square equal to 990. Okay, this is the most important equation. If I simplify, what I will get is a square plus 10d square equal to 90. Okay, now this is one, and the first term we know a minus 5d, which is equal to 15. So a equal to 15 plus 5d. Okay, you substitute this a equal to 15 plus ad value, okay, this value here, then we will get everything in terms of d, right? So if I substitute, then the quadratic equation I will get is 35d square plus 150d plus 135 equal to 0. Okay, or if I divide it by 5, I will get 7d square plus 30d plus 27 equal to 7. Okay, I factorized it, and what I will get, d is equal to minus 3 or minus 9 by 7. These are the two values I get. Okay, for d equal to minus 9 by 7, okay, what I will get is a equal to 15 plus 5d, okay, and which is equal to 60 by 7. a2 is 60 by 7 minus 4 into minus 9 by 7. Okay, I am substituting this a2 value here basically. Okay, so a2 equal to a minus 4 into minus 9 by 7. Okay, d, this is d value, right? Okay, minus 4d, which is equal to 96 by 7. Okay, that is more than 27 by 2. If I see here this value, okay, a2 should be less than 27 by 2, but it is coming more than 27 by 2, so this is not a solution if you take d as minus 9 by 7. Okay, for d equal to minus 3, a is 15 plus 5d, which is equal to 0. Okay, so this is a possible solution. Okay, and then if I sum up, a is 0 basically, d is minus 3. If I sum up all the 11 terms and divide it by 11, what I will get is 0. Okay, because this is the middle term which is 0, and rest all are symmetric terms basically, correct? If A is 0 and D is minus 3, okay, I have minus one side plus one side, I'll get 0, right? So sum and divided by 11 is 0. Okay, next. Okay, xyz are real numbers such that x square plus x square y square z square form an arithmetic progression. Prove that numbers 1 by y plus z, comma 1 by z plus x plus 1 by x plus y also form arithmetic progression. Okay, so this is what we know. 1 by z plus x minus 1 by y plus z is equal to, okay, y minus x divided by z plus x into y plus z. Correct? Now multiply numerator and denominator with y plus x. Okay, just to make sure that denominator is same. That's what I am doing basically. Okay, so it will become y square minus x square, okay, divided by z plus x, y plus z, x plus y. This is cyclical, right? This is cyclical and all three terms are there basically. If you see these three numbers, the denominators are product here. Okay, and numerator is y square minus x square. So similarly I will get difference of 1 by z plus x minus 1 by y plus z, that is these two, difference of second term minus first term. This is also equal to, basically this is equal to y square minus x square. I am calling it d because x square, y square and z square are in arithmetic progression. So difference between y square minus x square is d. Okay. Similarly, I can show others difference also, d by same value z plus x into y plus z into x plus y, which means common difference is the difference between the two terms is common constant, which is the value given here. Okay, which is value given here. That means these three numbers form arithmetic progression, right? How do you prove arithmetic progression? Three numbers are in arithmetic progression. If they are ABC, C minus B should be equal to B minus A. Then they are in arithmetic progression. That's what I am trying to do it here. First I took B minus A here, B minus A, and I proved that B minus A is some D by some constant, some product here, and C minus B also is the same value. Okay, these two are same values. That means these three form arithmetic progression. Okay, yeah, thank you. So these are the variety of progression problems which you can see, which can come in Olympiad and other entrance exams. So these are very easy to solve. Only thing is you should just know all types of problems which can come. I will do at least one more video to solve these progression problems, and I am trying to get only variety of problems. I don't want to repeat similar problems, but for your practice you should do same problems, similar problems multiple times actually. So keep doing more and more problems. This is very easy topic which you should score 100% in this. Thank you.